This video describes our approach to defining the process limits and capabilities for any aggregates operation using belt scale data. The process begins by mapping the process. Plant layout is usually obtained from an aerial photograph or a Google Earth. It can be done by hand sketch also. Stockpile locations are determined so that it can be established what conveyors lead to what product. Basic configuration of the processing system is necessary so that equipment limits and capabilities can begin to be defined, at least based on manufacturer recommendations or field observation. Conveyors are all defined in detail because they are often the bottleneck in the process. Flow model is an analysis that shows the material coming in, going through the crushing system, going to the screens, and eventually coming out as products. The system requires field measurement initially to be able to establish what the limits and capabilities in the as-is condition are. And that's done with field sampling, or in this case digital photo imaging. With that information, we establish the potential yield and capacity rates for the various modes that we initially define, and begin the process of locating belt scales. The belt scale information is the key to understanding the heartbeat of your process. Crushers are the point where the work is being done, so the performance of the crushers is critical. It is the heartbeat of your process. The pulse of your process is measured using the belt scales. Belt scales are located on the in-feed side and the output side, but the most important belt scales are the ones that are within the crushing circuit. Once the belt scales are in place, it becomes possible to evaluate in real time the variability that is occurring in the process, as well as the yield and the rate. The information can be looked at in a variety of forms and include self-defined or locally defined targets, or targets defined from the data system analytics. This shows an example of the scale data overlaid on a process flow model, which would then be the indication to the operator how the plant should be configured to achieve results indicated for the particular mode selected. Detailed analysis can be carried into a combination of measurements that reflect what's going into the crusher and what's coming out in terms of the key products and the byproducts. The purpose of the analysis is to establish how to operate the plant to increase the yield of key products, thereby reducing the number of hours required to achieve the forecast production related to current sales. Once the scale system has been in place, the system automatically begins processing the data and generating reports that can be used to evaluate current performance as well as historical. This is what the scale data looks like when it comes in, recorded by the hour for each of the individual products. The system automatically generates reports showing the details for the different segments of the process, again by the hour, and including the tons and the operated minutes. There's a 7-day summary, so you've got a comparison of today's production or yesterday's production against previous performance. Individual scales data is shown, including the tons and the operating hours, all the critical statistics. The year-to-date results are summarized. The month-to-date is included, the past 10 days, the past 30 days, and the past 60 days. We have a projection that we provide using the year-to-date information, along with an estimate of how many more weeks of operation are going to occur, so that we take previous performance and project end-of-year results. It can be seen in the year-to-date data that capabilities in terms of ton per operated hour, ton per scheduled hour, and percent runtime give you an idea of what the as-is limitations might be. You'll also note that the yield detail is accumulated. The cumulative data from all of the belt scales automatically extracted and analyzed on a daily basis. Establish the performance benchmarks and capabilities. The auto-updating benchmark capacity and yield evaluation gives us a clear picture of what the maximum capabilities of each of the products that are being measured over a conveyor belt. So we can establish what the realistic limits and capabilities of each individual measured conveyor system might be. We use that in combination to evaluate under various circumstances what the potential yield in terms of key products and byproducts would be, what the potential tons per hour of those byproducts and key products, and also we look at the amount of time that is scheduled is actually run. With this, the process limits and capabilities for any operating quarry can be established in detail that has never really been practical before. Simply using belt scales to measure the operating variables, using the real-time interface to kind of begin managing the operating variables. The issue with managing data is taken care of by the system, with it automatically generating reports, providing the analysis of current performance necessary to evaluate potential improvement.